Alrighty, so we're kind of jumping back into things here on the material that we did not have on the quiz, right? We had learned some stuff that did not show up on the quiz, so maybe it would be a good idea to kind of like refresh that a little bit. So let me go back to where we were here. Okay, so we've been jumping around a little bit in the latter half or latter portions, right, of chapter 9. We started in 9.7, and then we jumped to 9.10, I think was the next section. Yeah, we did 9.10, and now we're going back to pick up 9.8. Okay, so in this section, 9.8, we're still talking about Maclaurin and Taylor series and things, okay? But this, we're going to focus on kind of like more generic kind of power series, okay? Things whose function, things that when they add up, maybe we don't know what the function would be kind of thing. But we're still working with them, okay? Doing stuff, kind of stuff. We're identifying, for example, when the interval of convergence for that power series, right? That was the homework we just talked about there, okay? Trying to figure out, if the power series will converge for all x values, right, or just a certain x values kind of thing. And so, 3 different scenarios here. The majority of the time, we're going to be, working with that b, where we're going to have, a certain interval of convergence, right? There will be some situations we've seen where it converges, where our power series will converge for all c values, right? And there'll be some situations also where our power series will only converge when C is, when your center is just, C at the single point C, but no other point. And then we'll have this kind of radius idea too. All right. And the major ways that we're testing these power series, right, is using geometric or ratio tests, right? Going back to those, 2 tests from our previous unit on sequences and series, right? We can use those because both geometric and ratio, show convergence for a particular interval, right? For the ratio test, it's the next term divided by the previous term, or the next term times the reciprocal of the previous term must be less than 1, right? And then you check your endpoints as well once you kind of get that interval. And I don't think there were no geometric ones that really showed up for our examples here. So that's what we did for all these. All right. And then we just did some more kind of like practice with some other stuff too there, right? We wrote out a first 4 non-zero terms for sine of x, right? And then we saw that sine of x converged, for all numbers, which again, makes sense because we knew that sine of x was exactly that, certain series and stuff. And then here we had another Taylor series that we worked with too, again, just doing interval convergence and stuff like that. All right, so turn the page there and we'll get into then power series manipulation, okay? So in addition to kind of like showing intervals of convergence, we can also kind of play around with these power series some and do some other things. We've kind of done this already, right? But we're gonna do it some more here now too. All right. So since these series represent different functions, then we can manipulate the series the same way that we would manipulate functions, right? And we've kind of seen that already, right? We've already kind of differentiated and integrated, right? But we can also find extrema, points of inflection, all that good stuff. All right. So here we've got a power series, right? A certain function that we don't know, right? We're going to say is equal to this particular power series, okay? And then we want to evaluate the following. So first thing we want to do here is find the first 4 terms and the general term for f prime of x, okay? And then we're going to evaluate f prime of 0, and then finally we'll also evaluate the 11th derivative of f of 0 as well, okay? So let's find the first 4 terms and the general term there for f prime of x. All right. So what might be helpful here for us to do is to find, well, the first 4 terms maybe of the original function. All right. So let's just find f of x and write the first couple of terms for that. Okay. So notice here we are not doing Maclaurin, we're not doing Taylor, so it's not going to be it's not going to be that typical format we were used to on the quiz and stuff. We're going to just use this series right here. This series is what determines our function. So we're starting at n equals 0, all right? And in fact, it might be a little bit helpful here to simplify this just a little bit. That -1 is being raised to the n, and this x is being raised to the n as well. So since they're the same power, we can actually combine them together and say this is really just the sum from n equals 0 to infinity of negative x to the n power over n factorial, right? That might be helpful for our purposes and stuff. Okay, maybe not though, I don't know, depends. Okay, so we'll plug in 0 here for n, so it's going to be negative x to the 0, which is just going to be a 1, over, and then 0 factorial, which is going to be 1. So we end up with just, kind of a 1 there, right? All right, the next term then will be n equals, so that was n equals 0, right? And so n equals 1. So n equals 1 will be negative x to the 1, so negative x. So minus x over, and then 1 factorial, so just 1 again. I'll have to go ahead and write the 1 factorial in there, I guess. Okay. And then, let's see, we go again with the first 4 terms, so we'll go, let's see, n equals 2 then as our next term. So negative x to this 2 will be positive x squared over, and then 2 factorial. And then minus x to the 3rd. I think you guys maybe will get the idea there, over 3 factorial, so on and so forth, plus, and then dot, dot, dot. So there's our first 4 terms. We don't need to write any more, but we do want to write the general term too. So let's go ahead and do that. Okay. So for our general term here, well, what's going to go, we have a numerator and denominator, right? So what are we going to put in the numerator of our general term here? How is the numerator changing for these fractions? What are we going to write? Yeah, x to the n, right? Isn't what just the general term? Yes, what we're adding up. Exactly right. Yeah, it's the thing from the summation there. Yeah, exactly right. Okay, we're just going to repeat that, right? I mean, that's how we got these terms in the first place, right? So it is exactly that. That's what our general term is going to be. But of course, this is not the answer, right? We're doing this to help ourselves out because we're not interested in f. We want f prime. All right, so we're supposed to take the derivative here. Okay? We're supposed to take the derivative here. And so, well, what will the derivative of our first term be? Okay, well, it wouldn't be does not exist. Well, derivative of 1 is just 0. Yeah, derivative of 1 is just 0. Okay? How about this one here? What's the derivative of x over 1 factorial? Just negative 1, right? It's just going to be minus 1 there. Okay, right? The derivative of x squared over 2 factorial. Well, here I'll start to write this out a little bit more, right? So let me just take a step here. So the 2 factorial is a constant, right? And we could really call it 1 over 2 factorial. So let me just rewrite. We only have to take the derivative really of the x squared there. So it's just really 2x over 2 factorial, right? Because 2 factorial is a constant. So it's really just the x squared whose derivative we're taking, right? Likewise with the x cubed there, right? What's the derivative of x cubed? Well, 3x squared, right, over 3 factorial. Okay. Now, granted, it says the first 4 terms here. Technically, we have the first 4 terms, but I'm going to go ahead and come up with one more term here because I feel like, it's probably really wanting the first 4 non-zero terms, okay? So I'm going to go ahead and do one more term here for that purpose because, 0 terms are not very interesting. So we'll do one more. And that one, so it would have been x to the 4th over 4 factorial. So this could be then 4x cubed over 4 factorial minus dot, dot, dot. And then, what would the derivative of the general term be? Okay. Well, again, negative 1 over n factorial, that's a constant. Or you can think of that as like the coefficient. So what's the only thing that we're really going to be taking the derivative of here when we take the derivative of this general term? X to the n, right? We are taking the derivative of just with respect to x here, right? And so that's one thing I want to point out here, right? When you see that f prime of x, remember that means the derivative of f with respect to x. So those n's, all these n's that you see, you're like, well, should we be taking the derivative of n too? No, okay. Oh, the only variable here whose derivative we're trying to find is x. Okay, everything else we're treating like constants. Okay, n is just going to be a constant in this case. So then, what is the derivative of x to the n? So we bring the n out front. So nx to the what? N minus 1 power, right? It's just like it's exactly the power rule there. Okay, but of course this simplifies a little bit, doesn't it? Okay, well 0 is going to stay 0, so I'm just going to leave that. So we'll have negative 1 there. The 2 over 2 factorial, well, how is that going to simplify? It'll become x over what? 1, or 1 factorial if you like there, right? The 3 over the 3 factorial, well, again, remember, 3 factorial is 3 times 2 times 1. So the 3 and the 3 will cancel, and we're left with 2 times 1 still. So this is going to be x squared over 2 factorial. Right? Because, again, that lead 3 there is going to cancel out with the 3 there. So maybe I should kind of like go like this to just kind of show things. Okay? Plus, and then again, same thing here. 4x cubed over 4 factorial will become x cubed over what? 3 factorial. 3 factorial. Okay? And then minus dot 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 plus, and let's simplify this here as well. So the negative 1 to the n. The n and the n factorial are going to simplify. So we'll have negative 1 to the n, x to the n minus 1 over, and then what's going to be in the denominator now? N minus 1 factorial, right. Okay, and so there is f prime of x, as we were asked to find it, and its general term as well. Okay, so questions on any of that? Questions on the steps there? We're all okay with that simplification of the factorials? Very important that we can simplify those factorials like that. Okay, or it's very helpful that we can do that. All right, no questions? All right, so let's then evaluate f prime of 0. We've got f prime of x, right? We don't know the actual function, right? We don't know what f of x actually is, but we're able to take its derivative because we are able to write f equivalently as a power series. And so here's the power series that is equivalent to f, well, f prime, I guess I should say. And so we just need to evaluate f prime of 0. Okay, so f prime of 0. So let's plug in 0 for x everywhere we see. So there's negative 1 plus 0 over 1 factorial minus 0 squared over 2 factorial plus 0 cubed over 3 factorial. I think you get the idea. Oops, minus dot dot dot, so on and so forth. Okay. What will the derivative of f be at 0? It's going to be negative 1, right? All these other terms after that, excuse me, all these other terms after that are going to go to 0, right? Because we're plugging in 0 for those x values. And so we get exactly negative 1. So there's f prime of 0 is equal to negative 1. Now we want to find the 11th derivative. Oops, I don't know why I put an underline there. Sorry. Okay. It is negative 1. You're right, Lincoln. Spoiler alert. It is negative 1. Okay. What's that? Sorry. Maybe Mario would have taken you up on it. Probably not, right? Probably maybe he would have. Maybe he would have. All right, so anyway, yes, the 11th derivative of f here is going to be negative 1. All right, so let's take a look here at where this is coming from. Well, the 11th degree term of our power series here. So let's think about what the 11th degree term would look like, right? Well, here's the generic kind of like term for, you know, this is for the any term. So for the 11th degree term, it would be negative 1 to the 11, x to the 11, over 11 factorial. Right, so again, this is the 11th degree term. Of f. Okay, so notice I'm not saying the 11th derivative of f at 0 is this thing. I'm saying this is the 11th degree term of f, right? The original function, that's the 11th degree term. Okay? Now, if we take 11 derivatives of this thing, okay, it's going to reduce the power, right? It's going to, you know, we're going to have the 11 out front, then the 10, then the 9, then the 8, then the 7, 6, 5, 4, 3, 2, 1, okay, down to 0. Any degree term that's smaller than 11, so the 10th degree term and smaller, when you take 11 derivatives of that, what will those end up being? So in other words, there's in this function f, right, the first degree term, if I take 11 derivatives of this, what's it going to go to? The first term here. The 11 derivatives, it will go to 0, right? 11 derivatives of this thing, it's going to go to 0, right? The first one, it goes to 0, and then it just stays 0, right? this is this first degree term. The first degree term, if I take 11 derivatives of this thing, what am I going to end up with? 0, right? It'll be negative 1 for the first derivative, and the second derivative goes to 0, right? Second degree term, third degree term, so on and so forth. If I take 11 derivatives of these terms, they're all going to go to 0 until the 11th term, which will go to a number at 0. It'll go to like a constant, right? The 11th derivative, 11th term, and take its 11th derivative, it'll go to a constant here. So what's it going to look like? Well, the 11th derivative, I'm running into my other space here, but we'll just do it right here. So the 11th derivative, okay, will look like this. So what's negative 1 to the 11th? Negative 1 times, and then x to the 11th. Okay, well, if I'm going to take the 11th derivative, that means the 11 goes out front, so it'll be 11 x to the 10th, and then 10 times 11 x to the 9th, and then 10 times 11 times 9 x to the 8th, so on and so forth, and it's eventually going to go down to 11 factorial over also 11 factorial from the denominator there, right? And what happens to those 11 factorials? They cancel. And we're left with just negative 1. Okay. So we end up then with negative 1 being our answer for the 11th derivative. Okay, so we get negative 1 there. Question, Kara?
How do you go from x to factorial?
So the idea is here, right? Well, so let me just do it this way, maybe. Again, f of x, it's going to have some terms leading up to. Let me go to this. Okay, so the original function f of x is going to have some terms, a 0 degree, 1 degree, 2 degree, all the way up to 11th degree, and it's going to have more terms after it, kind of thing, right? So let's just take that first derivative. Okay, so the first derivative, again, you're going to have some derivatives leading up to that, plus, and then these constants will stay the same, and really it just becomes then, whoops. See it? And then if I do the second derivative now, again, stuff leading up to it, negative 1 to the 11th, and then bring 10 out, so now it'll be 11 times 10 x to the 9th over 11 factorial. And you can see then how the 9 and the 8 and the 7 and 6 creating then 11 factorial. Okay? And so we leave then with those canceling out, we get just negative 1 there. All right, and that's the idea. Which is handy because taking the 11th derivative of this otherwise would be pretty time consuming, right? Evaluating all those derivatives and things, but we have that nice pattern that works out. All right, let's continue on here. So letter B asks us to find the first 4 terms and the general term for the integral of f of x dx. Okay, so the integral of f of x here. Oh, thank you. So we're going to integrate f of x. So I already have f of x written out here. Okay, so let's just look, right? So if f of x, the first term is 1, well, what's the integral of 1? X, right? So that's our first term. Okay, the next term is minus x over 1, or just minus x. What's the integral of x? X squared over 2. So we're going to have minus x squared over 2. Okay?
Without the factorial.
So you can put the factorial in there if you want there. It would be times 1 factorial there, like that. Okay, maybe not a bad idea to do for our case here. Okay? All right, the next term. Next term we have x squared over 2 factorial. Again, the 2 factorial is just a constant, so really we only need to focus on integrating x squared. What's the integral of x squared? X cubed over 3. So it'll be x to the 3rd over 3 times, don't forget there's a 2 factorial though in the denominator there. Right? And then again we want 4 terms, so we'll do the next one here, which remember was x to the 4th over 4. So, well, sorry, never mind. Well, yeah, we got that. So yeah, integral x cubed will be minus then x to the 4th over 4 times that 3 factorial there. Plus dot dot dot. Okay. Plus. And now we're going to integrate this thing. Again, this negative 1 to the n over n factorial, that is a constant or a coefficient. So the only thing we really have to integrate here is x to the n. Okay? What would the integral of x to the n be? X to the n plus 1, right? We add 1 to our power and divide by the new power. Okay? And then don't forget we still have the n factorial in the denominator there, so we'll multiply by n factorial, and we still have the negative 1 to the n in the numerator there. And so yes, that's it. And then of course we should put like a plus c in there because technically there is an indefinite integral here. Okay?
So you can simplify the n plus 1 and the n factorial, right?
Yes, in fact, all of these factorials simplify some, and I'll go ahead and do that right now. Yes, good call there, right? So 2 times 1 factorial is what? 2 factorial, right? Okay, x to the third. 3 times 2 factorial, 3 factorial, right? We're adding that 3 on to the 2 factorial, so it's just now 3 times 2 times 1. And then same thing here, x to the fourth. 4 times 3 factorial is 4 factorial, plus, dot, 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 plus, and then same thing here, negative 1 to the n, x to the n plus 1 over n plus 1 quantity factorial there like that. Okay, so it simplifies nice, and again, don't forget the plus c. Okay, so there it is. Okay. Questions on that? And again, we just had to write, there's the general term, there's the first 4 terms. So we're good to go on that. We're good to go. Okay. All right. Letter C then. All right. I'm going to have you guys, I'm going to help you get started here on this one, and then I'll get you started. We'll have you do part of it here too. Okay. So we're asked to find the first 4 terms and the general term for g prime of t, given g of t is equal to f of t cubed. So g of t is equal to f of t cubed. So let's go ahead and just figure out what g of t is going to be. So g of t is equal to f of t cubed. We already know what f of x is, right? Didn't we do f of x way up here in letter A? So you guys go ahead, write out what you think f of t cubed is going to be. Okay? So again, if f of x is this, including the general term, don't forget the general term there, then go ahead and write out what you think f of t cubed will be, using that same f. Okay? It's the same f as letter A. All right, we were talking about there also in the beginning of the directions. So go ahead and write out what you think f of t cubed is going to be. And I will do the same. And please also do the general term for f of t cubed as well, please. And if you're feeling good, then you can proceed if you want to from there. Like if you feel like you've got f of t cubed, that's g of t, we're trying to find g prime of t. So if you want to proceed from there, feel free. Say one more time, sorry.
If you raise the power to the power, you just multiply.
Correct. Yep, the power to the power. So you can use this if you want to, right? And just replace all the t cubes with that, or you can use this and just plug t cubes in there because you already have the first couple terms written out. So it's really your choice, right? There's a couple options here.
Hey, how's it going?
It's good, right? And yeah, if you want to simplify those, you can without if you want another step, I'm saying you
He's not that smart.
I'm not a smart man, but I know what love is.
Wow.
Remember, so since we're replacing the x's with t's, you probably want to make that t cubed t to the 6, t to the 9.
Jenny!
I like what you did right here, simplifying and stuff like that. So yeah, the first 4 terms would be 1.
Are you being serious? We watched it.
No,
We watched
no,
it.
because
Class.
again,
We watched
first
it.
one would be 1.
Miss Briggs' class for Americans. American Studies too. Dude, that was the
So
fun.
yeah, make it t. Make that t as well, because you're replacing x with
He's
t.
standing at the bottom.
There's like so many little like details you have to pay attention to here. So yeah. Okay.
I don't know what t cubed squared is.
So there's f of t cubed. There's f of t cubed. All right. But of course, which is equal to g of t. We're not interested in g of t. Okay. We want g prime of t. So that means what do we need to do to this? Take the derivative of each individual piece. So we'll find g prime of t then, which is equal to the derivative of, and maybe I'll line this up better here, g prime of t equals, okay, so the derivative of 1, 0, okay. The derivative of t cubed, 3t squared, and I'm just going to go ahead and write that as then just minus 3t squared. You can leave it over the 1 factorial if you want, whatever, I'll write over 1 factorial. Okay. And then the next one here, derivative of t to the 6th, 6t to the 5th over 2 factorial, right? Minus derivative of t to the 9th, 9t to the 8th over 3 factorial, plus, and now, again, here you could be like, well, Mr. Wood, there's 4 terms, right? 0's 1, 2, 3, 4. It doesn't say the first 4 non-zero terms, but I'm going to go ahead and just give us the next term here so we can have 4 non-zero terms. So anyway, you can kind of see the pattern here, right? It was t cubed, t to the 6th, t to the 9th. So the next one should be, we would expect hopefully to be t to the 12th. And so this is going to be then 12t to the 11th over then 4 factorial, right? Minus dot, dot, dot. Okay, and then plus right there. And then we're going to take the derivative of this thing. Okay? And the only thing we actually have to derive here, what's the only part of it we actually have to take the derivative of? T to the 3n, right? Remember that t to the 3 to the n is really t to the 3n. Okay, so I'm going to, again, rewrite the negative 1 to the n piece. That'll still be there. So what is the derivative of t to the 3n? Well, exactly, yeah, 3n t to the 3n minus 1. All over n factorial. Okay. And there's a little bit of simplification you could do with that general term if you wanted to. You know, for example, here, you'll see that the n in the numerator here can cancel out with this n factorial, okay? So if you wanted to, you could say this is really then negative 1 to the n, 3t to the 3n minus 1 over, and if I cancel the n with the n factorial, what will be left in the denominator? N minus 1 factorial, exactly right. Okay, so you could do that as well there. Okay, now, this is not the only way to do this problem. Okay? So an alternative here that we could have done, again, if we're trying to find g prime of t and we have this relationship, an alternative thing we could have done here is taken the derivative of this. All right? So let's think about that, right? If I'm trying to find g prime of t and I have this relationship, in order to figure out what g prime of t is, I could say g prime of t then is equal to, if I took the derivative of the left-hand side, I need to take the derivative of the right-hand side, right? What would the derivative of this right-hand side be? I'll give you a hint. You're going to use the chain rule here.
It's going to be that prime.
So, yeah, so 3t squared f prime of t cubed. Okay? So the derivative of the outermost layer, f prime of t cubed, times the derivative of what's inside, so 3t squared there. Now, that revelation wouldn't be so helpful for us in this problem if we were kind of like doing this problem on its own. But since in letter B we had just figured out not letter B, sorry, letter A, we had figured out what f prime of x was. This is actually helpful. So you could instead of doing what we did here, where we took t cubed, plug it in for f, and then took the derivative from there, we could have plugged t cubed into f prime's power series. So you could imagine plugging t cubed into all these x's here, okay? And then multiply that answer by 3t squared, okay? So each one of these also then gets multiplied by 3t squared, and you would end up with exactly the same answer we got right here. Okay, it would work out there, but I don't want to spend the time to do that, okay? Because it's just a little more calculation, but it would work out. You could do it that way, okay? So two different paths to take, because we already found, f prime. Oh, sorry, not here. Goodness, I was pointing the wrong thing. Pointed up here. Sorry, up here, because that's f prime. Okay. So again, imagine. Let me correct myself here. G prime of t then is f prime of t cubed. So imagine plugging t cubed into all these x's right here. Okay, and then multiplying all these answers by 3t squared. Okay, you can kind of see the first term works out, right? Because for this very first term here, there's no x to plug into, so there's no place to plug in the t cubed, but we'd still multiply it by 3t squared, and there's your first term, negative 3t squared right there, okay, for that g prime. So it's going to work if you do it for the rest of them too, and simplify and stuff like that. They are the same thing. Okay, so anyway, there's that. All right, questions on any of that? All right, let's keep rolling here then. So, given that f of x is equal to the integral from 1 to, sum from 1 to infinity of that mess, find the interval of convergence for f prime of x. Okay, so interval of convergence, we know how to do that, but before we can go about doing our interval of convergence stuff, what do we need to do first? Take the derivative of this junk right here. Okay, now, let's take a look at what that's going to look like then. So I'm going to do the derivative here straight from this. I'm not going to write out the first couple terms. So you could, if you wanted to, right? If this is like maybe tricky for you or something, you still don't feel quite comfortable, you could write out the first few terms of this thing, then take the derivative, and then come up with a general term again. I'm going to take the derivative straight from this though. Okay, because really that's what we need to do is just take the derivative of this. Okay, so the sum will stay the same. We're going to be taking the derivative with respect to what variable? X, right? So that means this entire chunk of our sum, it's a constant or a coefficient. You're going to treat it like a constant or a coefficient. Okay, so in other words, you kind of don't ignore it, I'll say, but there's the derivative. So in other words, our derivative will still have negative 1 to the n plus 1 in the numerator. It'll still have n plus 1 and an n plus 2 in the denominator. Okay, the only thing we're actually taking the derivative of is that x minus 1 to the n plus 1. Taking the derivative, right, we bring that power out front, so it'll be n plus 1 times x minus 1 to the n, right? So there it is. There's our derivative of the series, of that power series. Okay, but something simplifies. What simplifies here? The n plus 1s can cancel, right? That's nice. Makes it look a little bit less awful. Okay. And so I'm just going to write a few terms here, right? So the very first term, right, if I plug 1 in for n, it'll be 1 plus 1, 2. Negative 1 squared is going to be positive 1, so we're going to have a positive lead term. And then n, so it'll be x minus, so positive x minus 1 over 3. Okay. Minus, now for the next term, for n equals 2, so that's again n equals 1, n equals 2 here. So for 2, it'll be a negative 1, x minus 1, bless you, to the 2, over 2 plus 2, so 4, plus, and you kind of see the pattern from here, right? Then it's going to be x plus 1, x minus 1 cubed over 5, minus dot, dot, dot. You get the idea there. So there's your first couple terms. Okay? So now, you guys go ahead and determine the interval of convergence. Because I feel like at this point, right, this is the stuff we did 2 days ago. So this is review now. So go ahead and find the interval of convergence. Okay? Are we going to use geometric or are we going to use ratio for this?
Ratio.
Ratio, right. Yeah, please use ratio here. Okay? So go ahead and figure that out. Remember, you can drop the alternating piece because it's going to be absolute value, so it won't matter if it's positive or negative. Oops. Okay, so go ahead. So since we're using the ratio test here, are we going to have to check the endpoints of our interval convergence?
Of course.
Of course, right. Bless you.
You take the derivative in terms of
X or
X. I took the derivative in this case with respect to x because our function, right? If we were taking the derivative of our function, oh, sorry.
do you do a
Oh, I apologize. So because we're taking the limit, it's n that's approaching infinity there, you take the derivative with respect to n at that point for the L'Hopital's rule.
Okay.
So yeah, so it's going to become 1 over 1.
Okay.
Is it okay so far? Not sure what to do? Okay, so take the limit as n approaches infinity here. So it might be helpful to simplify it first, right? So what I like to do is to kind of collect like these terms together. X minus 1 to the 1. So let's go ahead and write limit n approaches infinity. And so then yeah, so x minus 1. And so then actually I'm going to leave that over 1. You can put it. You can just leave it like that. It's fine. But,
Is that n plus 2 needs to stay up there, right?
so yeah, so you could have written that. That was fine. That was what you had. So just write x minus 1 parentheses there, and then over here to be exactly 1, and then put that over your n plus 3.
Okay.
And then close parentheses. And again, equal to the less than 1 there, just for yourself to remind yourself. Okay, so now, depending, and actually you can put x minus 1 there too, so not a bad idea, just to make sure they're grouped together. Right? Okay, so what's this going to approach as an infinity over infinity, which is going to be indeterminate. If you take the derivative, right, it'll be then 1 over 1. So this is really going to go just to x minus 1 then, right? So you can then just say, so you can drop the limit then at this point and say absolute value x minus 1 is less than 1, and then proceed from there.
Okay, I'm gonna write it out. Just
Sure, yeah, do that, that's fine.
Did I get the correct answer?
You have the interval convergence?
A little bit.
A little bit. That's a race, right?
Yes, that's a race.
Wait, what was
I screwed up.
what was x minus 1 to
But like
0?
So,
because like it gets
that'd be 1.
So would it be?
So remember, you want to check this in the series. So maybe our simplified version of the series, which is right here, I'd say. So plug the 0 in there.
Yes, I did. Oh, I plug in for
Yeah, plug in for x. Yeah, I know, right? Because, but again, this makes sense because we're trying to find f prime of, so this is x.
Yeah,
We're
but
testing
it's
these
not
x's.
always, it's always negative.
So I like to collect my terms together when I reorganize them. I kind of like to collect the x's in one part of the product and then my n's in the other part of the product. Rearrange the terms. And I can see that's going to go to 1, right? D coefficient 1, D coefficient 1, same degree of freedom. I didn't show the apply L'Hopital stuff, but
It would be n,
good job
it would
there.
be n to the 2 plus 1. And, no, sorry, negative 1 to the 2n plus 1.
Good to go from there, you think? Yes. So you apply L'Hopital, very good. You're going to apply L'Hopital to n because it's n that's approaching. Now n is our variable because n is approaching infinity here. So we're using n. So the derivative of n plus 2, 1. Derivative of n plus 3, 1. So it's 1 over 1 times x minus 1. So it's going to be x minus 1. So then you can drop the limit as n approaching infinity part. And that x minus 1 will be less than 1, right? And of course, it's absolute values, right? Its absolute values are this, this.
There must be a difference between how you.
Good, and now that allows you to set up that interval where you're gonna go then, after x minus 1 less than 1 becomes negative 1 less than x minus 1 less than 1.
How you
and then
doing?
Solve x there, and you can check your endpoints.
Just kind of plug it in for the best.
Look, check your endpoints yet. You know how to do
It'll
that?
always be negative.
Okay, so you're gonna take the 0 and 2. Okay, you're gonna plug this back into your series. The simplified one, I see here. Like that. Okay, you did it right here. Okay. So now, simplify, right? So same base, you can add your exponents. So 2 n plus 1. Okay, so this doesn't alternate, right? It's always odd, and so it would be negative 1. Okay. But then over n plus 2. So then the idea is, well, does the series converge or diverge? It's going to diverge because you're going to compare it to a P series, which is 1 over n. That would diverge. So
You're gonna get a reduction.
yes, go ahead. Right. We're still going to be doing example 7 too, so and 6 as well.
Good,
So
normal.
you plug
I've never had
0
zero.
into, I would say, your
Of course,
simplified.
I've never had a diagnosis. Now,
And see
I've
if that series.
I've been driven out of blurry lights before, yes.
0 minus 1 will be
Have I
negative
had
1.
slurred
Negative 1 to
language
the
too?
n. Right? Negative 1 to
drink
the n
water,
times
say it was fine.
negative 1 to n plus 1, you can add those exponents together.
Who
Negative
did?
1 to 2 plus 1, which is always odd, doesn't alternate, and so therefore it's again just like to use a series test.
Wait till we. No, you'd have a concussion.
No, it was so dumb. And like,
The n term for this one?
I've been one of the few kids who hits with their head straight down and never gives a concussion.
oh my god, I really.
One more year, but
Replace
that's.
then, replace the x's with the
That's
b.
with like beach stuff though.
You have a concussion on that?
Probably.
We gotta knock
We
it
got
off.
that x right there. We got that x right there. Replace with
The
b.
first time.
Then you have
Okay, that's fine.
First three.
But you do the first one.
Integrate
Oh yeah, I went two,
your
and then
terms.
three.
No, that's
So-
10.
so- There's
The first one makes it work, the second one cancels it out.
she's gonna integrate all these with respect to well t, but then you're
How
gonna
about I just never knock on
so it's
wood?
basically like
Just
taking the
like.
t, integrate with respect to t.
I know, so I was like,
Oh,
oh,
I haven't broken my arm since the second grade.
next day I broke my arm.
When she was in
Alright.
No way.
Well, it was my arm, it was my thumb, but I still in cast.
Dude, I don't understand why they put you in a whole
Sign is
cast
on.
It was
for a
this
big.
part of my thumb.
Next to the one.
No, but even like if you break like this part of your knuckle up here of your thumb, they put you in a whole
Okay.
cast. I don't know why.
We gotta keep rolling here, so let's do that. Alright, so example 5, you should have gotten 0 to 2. Include the 2, exclude the 0. Okay? So let's see here.
These problems take 4 hours.
Yeah, they do take some time. They do
So
take some
we're
time.
gonna have a, so it's not gonna be a time test.
No, it will be, but you won't have a lot, right? So, questions on example 5?
A 2-day test.
Yes?
I get why you don't include the zero, but why do you?
Why do we include the 2? So you're okay with not including the 0?
Yeah.
Okay, so check the 2, right, and you end up with this. Okay, this one does alternate.
Cosine. Negative cosine.
And so we're going to use alternating series test, and it'll converge by the alternating series test. And you can see here, I just did like the little check here. But you don't, I mean, again, you know, you got to really judge about how much, you know, like judge how much time or whether you're looking for this kind of thing. But I mean, you could just look at it and see it's going to alternate, right? You can kind of like mentally do these little checks if you need to, and then just see, yes, it will be alternating, will converge by the alternating test, so 2 will work. Okay. And again, there are the 2 conditions for that alternating series test to work. So, any other questions? We got to keep rolling. Sorry. Okay, because I want to make sure I get through 6 and 7 here. All right, so number 6, find the first 3 non-zero terms. Oh, and the general term for the integral from 0 to x of sine of t to the 4th dt. Okay, so maybe before we go about integrating sine, right? Maybe let's go about and integrate, or let's just figure out what, before we integrate the sine of something, let's figure out what the sine of that something would look like as a power series. Okay, so, well, let's see here. We know that sine of x, all right, that's the odd one, right? So it's going to be x to the 1 over 1 factorial minus x to the 3 over 3 factorial plus x to the 5 over 5 factorial minus x to the 7 over 7 factorial plus dot 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 plus negative 1 to the n x to the 2n plus 1 over 2n plus 1 factorial like that. Okay, so that's sine of x. And so then, of course, we're not trying to integrate sine of x, though. We need to integrate sine of t to the 4th. So maybe we should identify what sine of t to the 4th is. So that means to find out what sine of t to the 4th is, what do we have to do with all these with this t to the 4th? Into all of the x values, into all the x variables, right? So it becomes t to the 4th over 1 factorial. And I'm going to go ahead and simplify the exponents too. So t to the 12th over 3 factorial plus t to the 20th over 5 factorial minus t to the 28th over 7 factorial. So some pretty crazy high exponents there. I'll do the same thing here for the general term. Only the x gets replaced by t to the 4th there. So it becomes t to the 8n plus 4 power over 2n plus 1 factorial. Okay, and now we're going to integrate this thing from 0 to x. Now we're going to integrate this thing from 0 to x. Okay. So, let's kind of like, before we kind of maybe jump into this, or maybe you've already jumped into it, that's fine, okay? The integral of this thing, that means we're going to integrate each one of these terms individually, right? And then since we're trying to evaluate from 0 to x, we have to plug in the upper limit minus the lower limit plugged in. But what do we know about our lower limit? It's going to be what? 0, right? All of these terms, when we integrate them, will have a t in it. When we plug the 0 in for those t's, these all become 0. So our lower limit disappears. Our upper limit, all that's going to be done is once we've integrated, we're just going to plug in x for t. So in other words, we're just going to basically integrate each one of these terms and then replace t with an x, and that's it. So integrating t to the 4th will become t to the 5th, but we're going to plug it in, replace it with x, so it'll be x to the 5th over 5 times 1 factorial. Oops, I got ahead of myself. There you go, like that. Okay, so x to the 5th over 5, right? T to the 4th becomes t to the 5th over 5. Make it x to the 5th over 5 times 1 factorial. Okay, minus t to the 12th. That'll become x to the 13th over 13 times 3 factorial plus t to the 20th becomes x to the 21st over 21 times 5 factorial. We only need the first 3 non-zero terms, so I'm not going to even worry about the t to the 28th one. Okay, that's all we needed, so I'm just going to use that. Minus dot 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 plus, but we are going to get that general term, right? So negative 1 to the n. Okay, so we're going to integrate t to the 8n plus 4. We add 1 to our exponent, so it becomes x to the 8n plus 5 over the quantity 8n plus 5, that new power, right, times 2n plus 1 factorial. Okay, yes, Kara, sorry.
Why did it switch from 2 to x?
Because our upper limit for the integral is an x. So we integrate and then we replace the upper limit with x. Or replace x, inside for the upper limit there. And then the lower limit is 0, so it just disappears. We don't have to worry about then subtracting the lower limit kind of thing. Okay? Now, let's not lose what we just did right here. Okay, let's not like kind of like gloss over what we just did right here. This is a bigger deal than maybe what you just think, right? We just kind of went through something that like we've been practicing for a couple examples now. But look at this integral, right? Before power series, were you able to integrate this thing? No, right? You could like let u equal like t to the fourth, but then your du would be 4t cubed, and you don't have that here, right? And like integration by parts wouldn't really work here either. So we just integrated something that we, prior to this, were unable to integrate, right? We have now a series that is equivalent to this integral, right, that we otherwise wouldn't be able to do. Okay? So this is, again, a representation kind of what your calculator is able to do, right? Because your calculator can do stuff like this, right? And this is, again, your calculator doing this. It's using these power series to approximate it and get it to a close enough approximation for our purposes, And we'll talk about how it calculates the error and stuff a little bit later. All right, moving on. Okay, so given f of x equals cosine x minus 1 all over x squared, find the following using series. Okay, so we're going to find the limit as x approaches 0 of f of x. Then we're going to verify it using L'Hopital's. So we're going to have to build this function, right? We don't have this function, but what part of this function do we know already? We know the cosine, right? We know cosine of x is equal to 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus dot, dot, dot. It doesn't ask for the general term here, so I'm not going to bother with that. Okay. You guys go ahead and build up to the cosine of x minus 1 all over x squared piece. So go ahead, build up to our function there. Yep, so exactly right, Maddie, for that first step there. So for you, Lander, right? Subtract 1 from both sides to get the cosine x minus 1, right? So subtracting 1 from both sides, you have cosine x minus 1 over here, and subtracting 1 here. The 1 would just go away. Your first term would just be negative x squared over 2 factorial. And then, of course, you want to add in the divide by x squared part. So divide both sides by x squared, and, to help you build and simplify, of course. So yeah, just again, this is an equation, right? So subtract 1 from this side, subtract 1 from this side. That 1's going to disappear, but every other term still remains. So it'll be negative x squared over 2 factorial plus x to the 4th over 4 factorial.
But if it's a minus 1 over here, wouldn't I add 1 over that?
What you do to one side, you do to the other side, right? If I subtract 1 on the left-hand side, I subtract 1 on the right-hand
Should
side.
be 0, and then, but every other.
And then everything else will be x squared over 2, x squared over 2 factorial, x squared over 4 factorial, so on. Yeah, good job. Well done. Yep, divide. Because again, when you divide each side of an equation, everything gets divided, right? Everything gets divided. Yeah.
That's, I'm literally like,
I was like, what? I was like, whoa,
Okay, so yeah, so subtract 1 from both sides.
a little quiet.
Right, because you want to make cosine x minus 1.
Real quick for this one, I don't understand how you look at that and see that.
So absolute value, at its definition, right, at its basic kind of understanding, is a distance from 0. So if you want the distance of this thing, right, to be less than 1 away from 0. If you want to be less than
Negative
1,
1 to 1.
exactly. Less
Okay.
between negative 1 and 1, right? That would be less than 1 away from 0 in either direction. So that's
Okay.
why you put it between negative 1 and 1, and you finish solving by adding both sides there, so you get the 0 and 2.
Okay.
Okay?
It's a negative amount. Definitely a negative. Idea from negative, negative to positive. got a question for you.
Yeah, because when we put in x squared down the bottom, it's negative 1/2.
You don't
What's
minus
that?
one, you subtract one from the first term. No.
Is that right?
That is, so, oh, I see. So when you subtract one from both sides here, right, it just goes from, I mean, it's just one minus one here, one minus, the minus one cancels out there. You don't need to add minus one into all the other terms. Okay, and so then you can simplify then dividing by x squared, right? When you subtract something from both sides of an equation, it just does, you just do it once. When you divide both sides of an equation, everything still gets divided.
Right?
It's true. So, okay, in the interest of time, we're going to keep rolling here. Okay, so there is your cosine of x minus 1 all over x squared. Okay, and again, that is our function that we're trying to find the limit of here. So now let's go ahead and do that. Let's take the limit as x approaches 0 of f of x. Right, that's what we're asked to do, which is then the limit as x approaches 0 of negative 1 over 2 factorial plus x squared over 4 factorial minus x to the 4th over 6 factorial plus dot, dot, dot. You get the idea, right? Okay. How should we go about evaluating this limit? Plug in 0 for x. Exactly right. We're going to use a direct substitution here. Plug in 0 for x, and what do we end up with?
Negative 1/2.
Negative 1/2. Okay. Now, it says to also verify using L'Hopital's rules. In other words, let's do the verify over here, because we didn't need power series for that, right? We could have just done this. Limit as x approaches 0 of f of x, which is equal to... Thank you, Sean.
I know what that fucking is.
Not bad.
That's what everyone says.
I'm just saying.
Better late than never, though.
No. Because now you're coming in like the last 10 minutes of class, you're looking at this, you're like,
What? Sean can get this part. This is stuff. This is review right here. So he's got this. So if we want to take the limit as x approaches 0 of our function, okay, the limit as x approaches 0 of this, right? If we do a direct substitution now, what do we end up with?
0,
0 over 0, which we know as a indeterminate form. So in order to evaluate this, we need to do what? Apply L'Hopital. Okay, so derivative of cosine is negative sine. Derivative of x squared is 2x. Now we'll direct substitute in 0, and we get...
0.
Oh, man. So we'll do it again. Derivative of sine is cosine, so it's negative cosine x over 2. Cosine of 0 is 1, so it's negative 1 over 2. Check, it works. All right, we did that. All right, we got one more here. We got to get through letter B. Letter B, part B here. And all we're doing here, I'm going to, well, I'm not going to focus too much on the general term. I guess we could do the general term, but I'm just going to make sure we get through the integral here. So we're going to now integrate f of x dx. Okay? Again, integrating a function that we otherwise would not be able to integrate, right? We don't know how to integrate that function. There's no, well, maybe.
sure we do.
No, I don't know. Possibly. But anyway, let's do it much easier, right? So, integral of cosine x minus 1 over x squared dx, right? That's what we wanted to integrate. And so, this is integrating then. What we know is negative 1 over 2 factorial plus x squared over 4 factorial minus x to the 4th over 6 factorial plus dot, dot, dot. You get the point, right? Oh, it says find the first 4 non-zero terms here. So let me come up with one more term here. Let's see, it goes 2 factorial, 4 factorial, 6 factorial. So I'm guessing that's going to be 8 factorial. And then x to the 2, x to the 4. So hopefully x to the 6th there. Okay. So we're going to do 4 terms where we integrate. Okay, integrating negative 1 over 2 factorial. Well, that's just a constant, right? And so it's just going to be then negative x over 2 factorial when we integrate there. Okay. Integrating x squared gives us x to the 3rd over 3 times the 4 factorial. Integrating x to the 4th becomes x to the 5th over 5 times 6 factorial. And integrating x to the 6th, x to the 7 over 7 times 8 factorial minus dot, dot, dot. And don't forget there's a plus c at the very end there too. Okay, it does say find the general term. All right, we'll do it. But now we'll start. We'll call this n equals 1, and then n equals 2, n equals 3 here, n equals 4. I'm not going to start with n equals 0. I'm going to start with n equals 1. Okay, so all right. What's one characteristic here you notice about our terms?
Positive, negative.
Okay, they're alternating. So we're going to have -1, and since we're starting at n equals 1, and we need that to be negative, so it's going to be -1 to the
And plus 1.
No, negative 1 and 10.
to the n, because -1 to the 1 will make it negative for the first term, then positive, then negative, so on and so forth. All right. What else do we notice about? Let's talk about our numerator then. Now, our numerator always has an x. Okay, but what about the powers of that x? It's yeah, they're odd, and so it's going to be 2n because they're going up by 2 each time. But 2n doesn't quite work. If I put 1 in, I get 2. I need it to be 1, so 2n minus 1 will also give us odd as well. Over, okay? And now let's see here. I guess, well, I started with 1 times 2 factorial, 3 times 4 factorial, 5 times, so it's 1, 3, 5, 7. So that's the same as the degree there. So it's going to be another 2n minus 1 in front. And then my factorials go 2, 4, 6, 8. Who do we appreciate? Not L'Hopital. So 2n quantity factorial. All right, and there's our general term right there. Okay, we made it. Good times. All righty, so that's it. Questions on any of that? No questions?
What's the test?
Good question.